Okay, so these are the Higgs videos that I'm doing right now. This is a jet energy scale. Quark Gluon Dorigo explains calorimeter with bias Higgs research, and it was done on September 29th, and today's November 15th, 2012. So the keyword search is from the HERA 1 to HERA 6 Higgs mass boson particle videos. This is based on a keyword researching, so this is research that we're looking at. Jet energy scale, so I googled it and it came up with Dorigo, wordpress.com. Quotes from a blog for educational purposes from twitter.com, Markoskin. Jet energy scale for total beginners, June 16, 2000 is when he wrote it. So I liked what he had to say, so I used his information here to explain what it means. So a jet is a stream of particles emitted when a quark or a gluon, well, let us take a quark here, things are the same, materializes into stable particles, not really stable, but so for detection purposes. We measure the total energy of the particles to try and determine the energy of the original quark, because the knowledge of the latter allows us to make important measurements and new discoveries. For example, we can find the signal of the Higgs boson, a particle which may decay to a pair of jets. We have a chance to see a signal if we reconstruct the Higgs mass from the energy of the emitted quarks. The jet energy is determined with a device called calorimeter, typically but not always composed by a sandwich of lead and plastic scintillator sheets. Particles interact with lead nuclei, create a cascade of secondary interactions. The resulting particles generate light as they transverse the scintillator sheets, and by measuring the amount of light produced by the process, we can tell how much of a mess the originating particles created. That is, how much energy they originally had. The goal is the conversion of light into a jet energy and the subsequent measurement of the originating quark energy. We model all these effects with a detailed simulation program. The program knows in detail how the detector is made, knows the physics of the interaction of energetic particles with matter, and knows how a jet is produced from a quark. We can thus study how the energy measurement is degraded by all the known effects. From a rather complicated method using both real and simulated events, we are able to determine a correction to the energy measured in the calorimeter. The correction is able to rescale the measured jet energy to match the one the originating quark had. We have a similar correction for the simulated jets, such that we can compare data in simulation after the jet energy correction. So there's a graph there that shows the bias and the width. What the graph shows is that the distribution does not peak at 32 degrees Fahrenheit as it should. The deviation of the peak of the distribution from the true value 2 degrees Fahrenheit in our case is called scale error. The shift indicates that the thermometer is indeed biased, of course. Every instrument has a scale error of some magnitude. Ours will measure 2 degrees Fahrenheit more on average. A calibration point is a great thing. It allows you to tune your measurement. From now on, when you read 64 degrees Fahrenheit with your device, you know the true measurement is roughly 62 plus or minus 0.2 degrees Fahrenheit. That's from DorigoWordPress.com. So September 29, 2012, 12:26 p.m. EDT. Formula from data. So I'm going to add the jet plus the stream plus particles plus quark plus gluon. I'm not going to say plus because it gets annoying. Stable particles. Measure total energy of particles. Energy of original quark. Measurements and new discoveries compared to energy of the original quark. Higgs Boson Signal. Particle. Decay. Pairs of jets. See signal, reconstruct, Higgs mass, energy, emitted quarks. Jet energy, calorimeter, lead, plastic, scintillator sheets. So this is from science.nasa.gov. Some sort of graph there showing the particles and stuff. So if particles interact, lead nuclei create cascade secondary interactions. Particles generate light. Transverse scintillator sheets, measuring amount of light, originating particles, create a comparison of the two. Goal, conversion, light to jet energy, measurement, originating quark energy. Detector, interaction, energetic particles. Matter, jet, quark, study, energy management, measurement, correction. Energy measured in calorimeter. Rescales measured jet energy. Matching originating quark. Correction. Simulated jets. Compare data. Simulation after jet energy correction. So you take your width, add your bias, add your distribution. Peak, deviation of peak equals true value equals scale error. Every measurement has an A plus minus scale error, average of 2 degrees. Calibration point, see bias, width, signal diagram. Okay, so that's it for that video. We'll go on to the next one.